Welcome back, everybody. We are up to lesson 3 of unit 4. Once again, there are new lesson notes today, so we are going to get right into the examples. In 1840, the population of Florida was about 54,500. Over the next 20 years, the population grew exponentially, increasing by 60% per decade. That is an important fact that I'm going to underline right here. Use the exponential growth decay formula to answer the following questions. Find the population of Florida in 1850. So we're going to use our exponential growth decay formula. In this case, because we're talking about the growth of a population, this is going to be an exponential growth situation. My initial value looks like is going to be 54,500. Okay. I'm increasing by 60% per decade. So 60% is 0.6 as a decimal. So according to our notes that we've been using, when it's a growth situation, my growth factor is 1 plus the percentage. So 60% is 0.6. So my growth factor is going to be 1 plus 0.6, or 1.6. So my growth factor is 1.6. And then the hint here is, what value should you plug in for x if the population is growing 60% each decade? So it's important that we realize, if I plug in x equals 1, so if I were to plug in x equals 1 here, that doesn't mean 1 year. That means 1 decade. If I plug in x equals 2, again, that doesn't mean 2 years. That means 2 decades. So they want the population in 1850. 1850 is 10 years later, which is 1 decade. So I'm actually going to have to plug in x equals 1, because 1 means 1 decade, or 10 years. So to figure out the population in 1850, I'm going to calculate this: 54,500 times 1.6 to the power of 1. So let's go to Desmos. So 54,500 times 1.6 to the power of 1. And we get 87,200. 87,200. So that is the population of Florida in 1850. Number 2, find the population of Florida in 1860. So when I plug into the formula, I'm going to have the same initial value. I'm going to have the same growth factor. Now, again, the question is, what am I going to plug in for x? So 1860 is now 20 years later. All right, 20 years is how many decades? 20 years would be 2 decades. So I'm going to plug in 2 for x, because 2 represents 20 years, or 2 decades. So I'm just going to simply replace this 1 with a 2, and I got 139,520. Okay. Number 3. Write an equation for a function p which models the state population x decades after 1840. So now we just want a general formula. The general formula is going to be 54,500 times 1.6 to the power of x. Okay, so the important thing to realize here is that x represents number of decades. So x equals 1 means 1 decade or 10 years. X equals 2 represents 2 decades, so on and so forth. Okay. Number 4, find the population of Florida in 1855. So in order to figure out what I plug in for x, I need to take the number of years and convert it to decades. So 1840 to 1855 is 15 years. 15 years is how many decades? Well, if it's 10 years per decade, I need to basically divide by 10, right? If I divide the number of years by 10, that tells me I have 1.5 decades. Okay, 15 divided by 10 is 1.5 decades, just like 20 years divided by 10 is 2 decades. Okay, so that means I'm going to plug in 1.5 for x. So 54,500 times 1.6 to the power of 1.5. So 1.5 is my x value. So let's go to Desmos and calculate that. Okay. I'm going to round this to the nearest whole number since we're talking about population. So the population is going to be 110,300. 110,300. Okay. Number 5, find the population of Florida in 1858. So 1858, again, that's going to be 18 years later. So to convert that to decades, I have to take 18 and divide it by 10, right? Since there's 10 years per decade. So 18 divided by 10 is 1.8 decades, which means when I plug into the formula, I'm going to plug in 1.8 for x. So 54,500 times 1.6 to the power of 1.8. Okay, so that is what I am plugging in for x. So that's 127,000. And if we round it to the nearest whole number, that would be 127,003. Okay, so there's your population in 1858. And then lastly, find the population of Florida in 1861. So 1840 to 1861, that's 21 years later. So again, to figure out what I plug in for x, since x is decades, I have to divide 21 by 10. All right, so 21 divided by 10, that's 2.1 decades. So it's going to be 54,500 times 1.6 to the power of 2.1. So 54,500 times 1.6 to the power of 2.1. And there's your population, 146,234. 146,234. So the key with this is that my growth rate was per decade, which means that my x value is decades, not years. That was the key to these examples here. And that is it for this lesson.